day, welcome back to our channel. I'm Maile Matsiba. Today we're continuing with our 2017 study guide of our CIR 113 module. We're looking at example 3.3, the very last example of section 1. It says the heat capacity Cp of sulfur is given by the equation Cp equals to 3.63 plus 0.640 T with Cp in calorie per gram mole Kelvin and T in Kelvin. Now they say note some more additional information. In the equation, Cp equals to 3.63 plus 0.640 T. T is the real temperature and not the temperature difference. In the units of Cp, which are calorie per gram mole Kelvin, the K denotes a temperature difference in Kelvin, or in other words, degrees Celsius. Now the question says, rewrite the formula to the form Cp equals to A plus PT, Cp equals to A plus Bt to calculate Cp directly in calorie per gram mole degrees Fahrenheit if T in degrees Fahrenheit is set into the new formula. Now, with that said, for us to actually tackle this, I just want to explain a few things about this problem statement. We have an equation here, it's an empirical equation, and in this equation, we know that the T is actually in Kelvin, and also the units of the Cp is in calorie per gram mole Kelvin. Now, there's something they are highlighting, that T is the real temperature and not the temperature difference. So there are two temperatures in this. We have the real temperature T in the equation, and it is in Kelvin. And we also have the difference temperature, the temperature difference, which is also in Kelvin. So there are two here, which now the question says, rewrite the formula to the form Cp equals to A plus Bt to calculate Cp directly in calorie per gram mole degrees Fahrenheit if T in degrees Fahrenheit is set into the new formula. So it's important to understand that if we're going to have an equation of this form, the form is not a problem, because actually the form is the same form. So if we're going to have an equation of this form to calculate Cp directly in calorie per gram mole degrees Fahrenheit, we need to understand something, that two things need to happen. We first need to convert the T, which is in Kelvin, into the T, which is in degrees Fahrenheit in this equation. That is the first conversion. This is actually the real temperature, right? And now the second one that we need to convert is actually the temperature in the units from Kelvin into degrees Fahrenheit. Notice the units have changed. It's calorie per gram mole Kelvin, and here we have the calorie per gram mole degrees Fahrenheit, which means we're going to change both the real temperature and also the temperature difference. So this takes us first to our step 1. So our step one says convert the real temperature T, which is in Kelvin, from the formula of Cp, that is actually this temperature here. Convert that temperature from Cp into the temperature T in degrees Fahrenheit. This is actually this T in degrees Fahrenheit, and calculate the new formula. That is our step 1. Of course, it's not the only step. Let me write formula properly. Formula. That is not the only step, but that's actually our very first step. And with that said, we need to understand something. If we're going to be converting the real temperature T, which is in Kelvin, into the real temperature T, small t, into degrees Fahrenheit, we need the ratio of T, which is the temperature in Kelvin, with the ratio of both T, the bigger T, and the smaller t. I hope that's clear. We need the ratio of the temperature in Kelvin to the temperature in degrees Fahrenheit. We need the relationship, or you can call it a ratio. So, but we know that T, which is the temperature in Kelvin, equals to T minus 32 all over 1.8 plus 273. This is something that we didn't even need to. This is something we know. We know this is actually an equation. We know that if you're going to convert the temperature in degrees Fahrenheit into the temperature in Kelvin, what you do, you take the temperature in degrees Fahrenheit, you say minus 32, both that over 1.8, and then you add, you say plus 273. This is a procedure that we all know, so it's nothing really big. So with that said, here we have the temperature in Kelvin, but here it's actually, here we have the temperature in degrees Fahrenheit. So which means now that we have this ratio or this relationship, we can actually replace this T with this, which means we can go to this equation here, or this equation here, and replace the T here, replace it with this. And we'll do just that. So well, let me just highlight here that with T as the temperature, temperature in degrees Fahrenheit. So therefore, if we know that this T equals to this, then we can easily say Cp equals to 3.63 plus 0.640, and in the position of the T, we replace it with this. We say T minus 32 all over 1.8 plus 273, right? Now, with this set, now with this equation, we can say with T in, oh no, sorry, with T, let me say, yeah, with T in degrees Fahrenheit. I think it's easily and clearly visible there. So this is actually a new equation, and now it simplifies further to when you do your arithmetic, your normal high school simplification. It's 166.97 plus 0.355556t, right? Now, I need to highlight here with Cp in calorie, with Cp in calorie per gram mole Kelvin, and T in degrees Fahrenheit. There's a very important principle I need to highlight. Check here, we have replaced the temperature, which is in Kelvin, right, with a temperature which is in degrees Fahrenheit. But the units of Cp are actually still calorie per gram mole Kelvin. Why? This is because we only converted the real temperature, but we didn't really convert the temperature of the units, which is actually the differential temperature. And another very much interesting question is that why is it that now, after we're going to be plugging degrees Fahrenheit, we're still going to be getting calorie per gram mole Kelvin? It's important to understand that if you look at this, the reason for that is actually in this bracket here. Just that I don't think it's a perfect time to actually explain it here, but I'll just try briefly if somebody becomes very curious about it. because in my time I was very curious about this. So what happens is this here, this is actually a temperature in degrees Fahrenheit. But this bracket here, if you look at it, it's actually Kelvin. So we have the degrees, we have the temperature in degrees Fahrenheit, right? But we converting that temperature into Kelvin. So that is actually the manipulation of the temperature in degrees Fahrenheit. So, and yeah, but it needs much more broad explanation, and I believe this might not be the perfect time for it, but should I find time, I'll find a perfect example to actually focus specifically on explaining that. And from here, it's very much correct mathematically that the CP, the units are calorie per gram mole Kelvin. So yeah, with that said, it takes us to our second step, step 2. Step 2, I can say test the equations or the equation, right? Equation or equations, it depends. It doesn't really matter, rather, sorry. So why are we testing? What is it that we are testing? There's actually a very much big confusion in the study guide. It's not really wrong, but if you don't have as much broader background, it might be very much confusing. They're talking about correcting units and the like, but it's nothing, it's not really there of a big issue here. The testing here is specifically to check the consistency of our two equations. Remember, we had an equation here in Kelvin, and it had CP. It was an equation of CP. It had units of calorie per gram mole Kelvin. So if we plugged in any, or rather now we have a new equation of Cp with T in degrees Fahrenheit. The whole concept of testing is actually to test the correctness of the equation, especially the second equation. Why? Because we need to know that there's still consistency. If we plugging in the same temperature, if we take a temperature in Kelvin and plug it here and get a value, and if we take that same temperature in Kelvin and convert it to degrees Fahrenheit, if we plug it here, it should give us the same value. That is the whole point of testing. So it's nothing that much complicated. So we'll do just that. Yeah, so with that, we'll say, for the first equation, we'll say Cp equals to 3.63. Okay, let me just write here. Let's say test the equations at 32 degrees Fahrenheit or 273, right? Yeah, so now we have Cp equals to 3.63 plus 0.640273, right? This gives us 178.35 calorie per gram mole Kelvin. This is actually the first equation. Now the second equation is Cp equals to, yeah, we have it here. Yeah, it's Cp equals to 166.97 plus 0.35556. Now our temperature here is in degrees Fahrenheit, and we know that 273 is equals to 32 degrees Fahrenheit. This also gives us 178.35 calorie per gram mole Kelvin. So everything is correct here. The equations is correct. The equation we've confirmed that is correct, and even the units are correct. Now there's something in the study guide that they actually are saying that we are correcting the units. That they need to be, when they reach here, they say they needed to convert the units. It's nothing really big. The units, the reason why they are saying they are converting the units, it doesn't mean the units are wrong here. The units are very much right. Remember, the equation says we need to give, it needs to have Cp directly at calorie per gram mole degrees Fahrenheit. So up to here, there's nothing really wrong. We just did half the job. We just need a third step where we actually finish up everything. So it's nothing so much complicated. So this then takes us to our step 3. So I'll just write step 3. I'll just write step 3. So with our step 3, we convert the temperature difference. Convert the temperature difference K in the CP units. These are the units, calorie per gram of Kelvin, in the CP units into degrees Fahrenheit. So now with that said, we know that when we reach here, we have converted the real temperature, but then we need to convert the differential temperature, right, from this equation. Let me just bring it the last time. We are done converting from T to the smaller t, but the units still have a Kelvin. Now we need to convert the units. And this is actually our step 3. Now we know that, or should I say, the units, this is the units of 166.97 are calorie per gram mole Kelvin. So the units of this constant are actually calorie per gram mole Kelvin. I guess it's much more easier. So if we're going to actually be converting, we need to convert this one to degrees Fahrenheit. So you can say therefore 166.97 calorie per gram mole Kelvin multiplied by 1 Kelvin. We know that 1 Kelvin equals to 1.8 degrees Fahrenheit. With that said, this gives us then, this then equals to 92.76 calorie per gram mole degrees Fahrenheit. So that is actually it. And the units of 0.355556 are calorie per gram mole Kelvin degrees Fahrenheit. Why do they have